Here is another video from page 337. This is number 82. Wow, we have a lot of videos today. That is super exciting. We're finding all complex zeros, giving exact values, and listing multiple zeros as necessary. And take a look at this polynomial. Notice we do have an x squared term missing, so we're going to need a 0 as a placeholder when we get to our synthetic division. First thing I want to do, even though it doesn't say we need to, is to make the APRR list, because that will tell us what our potential rational roots are. So look at the constant 8, list all of its factors, plus or minus 1, 2, 4, and 8. Those are the potential numerators of our rational roots, and then the leading coefficient is 1. So list all the factors of 1, plus or minus 1. And those are all the potential denominators. So those numerators over those denominators give us the list plus or minus 1, 2, 4, and 8. And those are the potential rational roots for this problem. So once we have that list, let's go ahead and make a synthetic division chart. And what I'm going to do is give myself plenty of room above and below, because I don't know how many rows I'm going to need. Start with the 0 row. We have 1x cubed, 0x squared, negative 14x, and then 8. And 8 will be our remainder. Put that in its own column. And then remember, what we do is synthetic division in this table, going in order, not skipping rows. So I'm going to go ahead and fill in some rows here. I'll talk through the first one, and then I'll pause and fill in the rest of them. So put a 1 in the box. That's for testing out x equals 1. Bring up the first number. 1 times the number in the box plus the next number in the 0 row. 1 plus the number in the box, 1 times the number in the box plus the next number in the 0 row. Negative 13 times the number in the box plus the next number in the 0 row. And so on. I'll do one more. Negative 1. Bring down the first number. 1 times the number in the box plus the next number in the 0 row. Negative 1 times the number in the box plus the next number in the 0 row. Negative 13 times the number in the box plus the next number in the 0 row. Okay, I'll keep going. Okay, hey, I thought it would be fun this time to do the negatives first, and look what happened. I kept going, plugging away until I did the negative 4 row. Notice I did the negative 3 row, and you probably think I am a glutton for punishment. Why would I do the negative 3 row when negative 3 was not in my APRR list? There's no way negative 3 is going to be a root. And that's just a habit I'm in, to always go in order and not skip rows because of what's coming next in our unit. And as the problems get more difficult, we're going to want to look for some patterns and clues in the remainders. And if we skip a row, we're not going to see the patterns and clues we need. But for this problem today, it wasn't really truly necessary for me to do the negative 3 row. I could have skipped it. I just don't like to get into that habit. But the point is, we found a root at x equals negative 4. And how many roots are left? Well, let's see. It's a cubic polynomial, so it has 3 roots altogether. And we just found 1, so we have 2 roots to go. Here's the key to getting the next 2 roots. Take this row, what you have left, and that represents your quadratic. Write it as a quadratic, 1x squared minus 4x plus 2. Set that equal to 0 and solve for the remaining 2 roots. If it's factorable, great, factor it and solve. But if it's not factorable, like this one, just use the quadratic formula. So x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. Simplify, we have 2 plus or minus square root 8 over 2. Keep simplifying because square root 8 is 2 square root 2. So 2 square root 2 over 2. Reduce, and we have 2 plus or minus square root 2. It said to keep the values exact in the directions. So we have our remaining 2 roots. So the 3 roots altogether are negative 4, and then 2 plus or minus square root 2. If we were graphing this polynomial, we would take these and put them in the calculator and get the approximate values, and then we would know what to graph. But for exact values, that's it.